Hello, everyone, and welcome to day 3 of lectures of the fifth annual Mars Society Design Engineering Competition. Before we welcome our guest, I would like to go over some logistics today. I am Nicole Willett, the Director of Education for the Mars Society. So, students, welcome in, welcome in. I just want to remind everyone, primary sources are essential. Artificial intelligence is not allowed in any capacity for this competition. If you or your team members use artificial intelligence, you will be disqualified as a team from the competition. It is up to all of you to work as a team together to make sure no one is using AI. If you have a problem or issue with your team, if you have not heard from your team, if your team is not collaborating properly, please email me today as soon as you possibly can. All videos of presentations are uploaded each day of the competition for you to watch. So for students who are unable to watch the live, they may watch later. You may also email me if you have any questions for the scientist. If you missed the live presentation, you may email me questions and I will forward them to our guest speakers. Speakers usually have a few minutes time for Q&A after their presentation. And I want to point out that Monday, June 15th, we start 1 hour later. So if you're here at this time Monday, I won't be here until 1 hour later. So 6 p.m. UTC Monday, we will have one presentation and then I'll have time for Q&A about your projects. Today we welcome Dr. Anika Mehlis. She will be speaking where the future of spaceflight begins, analog research and the human factor for Mars. She is a systemic counselor, scientist, and analog astronaut. She draws on microbiology, public health, engineering, psychology, communication, and space exploration. Her work connects ideas across fields to create clarity in complexity, making uncertainty more bearable, diversity more visible, and change more approachable. We are happy to have you here, Dr. Mellis. I will pin you on the screen and you have the con.
Thank you very much also for the kind introduction. I'm very happy to be here and to see so many faces. And I thought about how to best contribute. As you just announced, I have worked in a lot of fields, and for me, the common denominator turned out to be the human factor. Psychology, how people prepare for extreme environments and how we can adjust technology to best fit human needs. And that's what my presentation is going to be about. And I am going to share my screen. We checked before that it works. And I need to just a sec. As always, if you want to hurry. Okay, so I hope that you can now see the presentation. Okay, perfect.
Perfect.
Um, okay, so I will ask you several times throughout the presentation to either raise your hand for yes or no, or to write something in the chat. And starting to give me a short impression, who is already aware of the whole concept of analog astronauts? Then you can raise your hand so I can see I'm preaching to the converted already. Perfect. Okay. So you already know that to go on missions, no matter if it's to extreme environments on Earth or also in the future to the moon, back to the moon, or even onto Mars, preparation is everything. And you can now write in the chat if you know which expedition you can see in this picture. It's a very famous one. Hint, it's to the South Pole. And of course, if I want to see what you write in the chat, I have to open it for me. Sec. Okay. Anyone? It is the Fram mission. That's what it was called. It's Amundsen. who reached the South Pole as the first human in 1911. So a little bit more than 100 years ago. And of course, they did not set sail and just start. What they did before was they went to extreme environments in Norway, for example, and tested their equipment, the food they were taking, how many sled dogs they needed, and stuff like that. But also what kind of people they would take on this journey and how many people they would need and what different skills they would have to bring, stuff like that. And yeah, the most important thing separating successful expeditions from the ones that did not succeed was, of course, happenstance and environment and so on, but also the human factor. So if the team did not work well together, if some people mutinied or whatever, then such an expedition was set to fail. And the same is true for spaceflight. So for humankind to go back to the moon, as we are trying with Artemis at the moment, and onto Mars later on, we will need to do the same thing. We will need to practice beforehand. And to show you why and how we can do that on Earth, I brought two pictures, and both of them were taken on the same day. One is on Earth, and the other one is on Mars, taken by one of the rovers. So I would like the ones of you that think that the Earth is on top and Mars is on the bottom to raise their hand now. Okay, there's some raised hands. And I'm going to wait until they disappear again. And then we're doing the other way around. So the people that think it's the other way around, and we have Mars on top and the Earth on the bottom, can raise their hands now. And as expected, we have raised hands again, which tells us it's really very difficult to make sure to have the right one. If I would be outside of the presentation and I could move this line in the middle and draw it downwards, you could see that there's black rectangles in the upper picture. And they are there because the upper picture is done on Mars or was done on Mars and put together by several pictures that the rover took. So Mars is on top and the Sahara Desert actually is on the bottom on Earth. But you can see that there is remote areas on Earth that were also shaped by wind, by water, that are very similar to some areas on Mars. And that's where we are going as analog astronauts to try to prepare for future missions on Mars. And the Austrian Space Forum that I am working for trains and selects people in a variety of skills and fields. So we do train a lot of geology, as you can imagine, but also the whole technology behind it, spacesuit design, first aid, firefighting, communications, navigation, you name it, to prepare us. And then we do big Mars simulations every few years in remote areas. And I have been to 3 of those already. The first one was in 21 in the Negev Desert in Israel. And the picture up here is from that area that we did the mission in. And we also always have a mission architecture where we have a mission support center on Earth and a Mars habitat. And we simulate the 10 minutes time delay. And as you already know, due to the big distance between Mars and Earth, the 10 minutes is an average. It can be less, but it can be even more. And as you can imagine, if you are on the International Space Station and you have a lamp blinking, emergency, whatever, then you can just call Houston and tell them you have a problem, and they will look up in their manual and then tell you to press button Y, Z, whatever. But if there's a blinking light on Mars and you write in the chat that you don't know what the problem is, and 20 minutes later you get the answer that it might be the CO2 rising too high and you have 5 minutes left, then this information is too late, of course. So having all your workflows, your communication channels, and also the level of autonomy that people that go to Mars will have and test them beforehand is very important. And in all our missions, we already found a lot of things that could go wrong if people didn't factor that in. And you can see that we always have a lot of experiments from all the different fields of study, and there's a lot of people involved. Also, the invitation, if ever in the future you feel that you would like to participate in some of those kind of missions, there's education programs done by the ÖWF. Also, you can have internships and also take part in those missions in several capacities. So that might be something worthwhile to check out. And before I get started with, let's say, the takeouts and the lessons learned we already could take away from those missions, I want to show you a little bit how it looks like so you get a feel what to imagine if I talk about it. So the Mission Support Center that we always have on Earth, in this case, it was in Vienna. This is just one of the rooms. That's the flight planning room. And it's comparable to what Houston, for example, uses for the ISS. And then you have the habitat on Mars. And in the Negev Desert, it looked like this. So we had this two-part module. The angular shape back here, that was the living quarter, and the round one in the front were the laboratories and the airlock in front, the area where the spacesuit simulators were stored, and we used to don them and doff them before going on EVAs. And then you can see all the solar panels we had. We used quads in simulation of Mars rovers and vehicles. And the big orange things here are the containers that were used to ship everything there from Austria and back. You can also see the wastewater container back here and the water tanks up on the roof. Everything was self-contained. So we used the solar power and the generator for nights. We had the satellite dish here, and we had the wastewater system. So everything was, a closed system. And what we did, we were there for 4 weeks, 6 people isolated in the habitat, going outside only in pairs in the spacesuit simulators for taking samples, driving the rovers, stuff like that. And we simulated the exploration cascade, meaning that as you are designing right now, if a crew of people goes to Mars to look for signs of past or present life, of course, first you would have satellites picking out the best landing spot. Then you would send rovers, as we are doing right now, to select good areas that would be interesting. And then you send people that can work hand in hand with robots, rovers, drones, to pick the best spots to take samples. And only then would you use the very scarce time that people have on the surface due to the harsh environmental factors, and send them out to do the stuff that, as of now, only humans can really do in a sensible way. And that's what we also simulated, but also a lot of experiments going inside of the habitats. This is what our space simulators look like. That's actually me here in the front and my colleague Carmen Köhler. That was our first all-female EVA. Actually, that was quite nice being part of that. And one of the little rovers that we used for transporting our samples. And you can see that the crater that we were in and the red soil was really cool. And I saw the first question that in the chat, that when I put on the suit and stepped out of the habitat for the first time, what did it feel like? And I have to say, of course, we trained a lot with the suits before, so I knew what it would feel like to have the suit on. They're quite heavy. They weigh about 50 kilos. So you have to be really fit and trained. We have a strict training regimen beforehand. And afterwards, it feels like you ran a half marathon. But it's really great fun and interesting. And of course, you never forget that you're actually on Earth. But stepping out of the airlock, wearing the suit, you don't hear anything from the outside because the ventilators and the comm signal is too loud, and it's quite isolated. So you're setting foot on this red soil, seeing all this crater environment in the distance, no humans, nothing visible that is made by humans. You can really, like, for a moment, feel like what it could be like setting foot on Mars. So that was a really a great moment. Still gives me goosebumps if I think about it. So I'm really happy that I could be part of that. Yeah. And stepping forward, the second mission I did actually as commander of the crew of 6 people was 24 in Armenia. So we were in the mountains there, and you can see that the habitat that we had there looks completely different to the first one. And that's important, and why I will tell you in a while. You can see that it was built in like halfway inside the side of the mountain and really a long shape with big windows, actually. And we had the living quarters back here, all the laboratory stuff here, kitchen, laboratories, and then the airlock in front. And again, we did a lot of psychology, medical experiments. AI was tried out a lot in different capacities. And again, a lot of countries, a lot of people from all over the world taking part. And the experiments on the inside were also very interesting due to us trying to have fully automated systems growing food, for example, or trying out um, algae growing to clean the air or to also produce some more protein. So yeah, a lot of very interesting experiments on the inside. And then last year, I had the honor of taking part in the world's biggest analog. Maybe you've also heard of that. There were 15 habitats all over the world, 5 continents. Some of them were simulating Mars habitats, others were simulating Moon habitats, and we also had spaceships in transit, which is quite feasible. If you think about like 50, 70 years ahead, several different groups being on those on Mars or on the Moon or in space stations and so on. And you can imagine that this is a whole new level of complexity regarding information flow, communications, data, science, and so on. So I was leading the mission support center that was again centered in Vienna. So our task was every day for 2 weeks to keep track of all those habitats and all the science going on and all the media requests and stuff like that. So that was like juggling 100 balls at the same time. That was really an amazing experience. But I was also very tired afterwards. And to sum it all up and get to the human factor part and what we learned from all of that is that if you don't have a good feeling for what the humans need inside all this complex technology, then you will fail. So, of course, it's important to think about what to take, the water that you need, how life support will work, and all of that. But you also need to think about how people stay sane and safe and healthy, because it's not just for weeks. It's not 6 months on the ISS where you can just step in the shuttle and get back to Earth if something goes wrong. You are away from Earth for many, many, many months and you don't have a plan B. And that can really make people get strange, let's say it like that. So we do have some ideas from Earth, for example, from overwintering in Antarctica or some science stations in the polar regions of Earth or the military prisons, expeditions, stuff like that, and also analog research. And we do know some of the phenomena that we are expecting that we will see from people going to Mars, and we can almost already be sure that they are going to be more like bigger and longer and heavier and so on. So what are the criteria for healthy crews on long-term missions and how, and that's maybe the most interesting part for you in this exercise, how does habitat design, for example, spaceship design, factor in on the well-being and the performance of human beings? And what do you need to make them feel in a way that they are able to perform on such a long-term mission? And again, as I already said, we do have a lot of things that we can use from Earth. There is a lot of long-term studies already. I'm quite sure you've heard of some of them. So NASA does studies, ESA does studies, Roscosmos has done the Mars 500 study, for example. And I guess you also know those pictures here. Who knows which habitats are visible in those pictures? Again, if you know, then you can just raise your hand so I get an idea. And while you're doing that, I can check for more questions in the chat that I can factor in. I see some raised hands. So it's biosphere in Arizona on the left and high seas in Hawaii on the right. So two habitats that have seen long-term analog missions. Um, and what we got out of all this data that we already looked on is that there are some buzzwords or let's say, yeah, things that we are expecting that we see in most or all of those environments and missions. So we do have the problem of isolation. We are far away from everyone else on Earth. But again, we are also very confined and close together with very few people that we have to, yeah, spend time with if you want or not. We have long stretches of monotony, strange word, and boredom. And then all of a sudden you have a lot of stress and you do have crisis and you have to be creative and you have to be productive on the spot and find solutions. And then again, you have a few more months of boredom and monotony. Then let's try again the whole, have you heard of that? Who of you knows what the third quarter phenomenon is? Have you heard of that? So that's a phenomenon whenever people are in a special environment, and maybe you've already also experienced it yourself. For example, if you are on a class trip, or in the summer you are on a camp or something for maybe let's say 2 weeks or 3 weeks, and or you are doing a year abroad somewhere else, something like that. Then about after 3 quarters, people experience a drop in their mood. They are less productive. They sleep a little bit worse. They might be a little bit depressed even, or at least a little bit less enthusiastic about things. And that seems to be due to the excitement from the beginning is over, but it's still a long way to go to the end. And due to the time that you already spent, you already know what's going to be expected from the last few weeks or months. And it doesn't matter if it's 2 weeks or if it's a year, it's always around 2 or 3 quarters. So that's also something that I experienced during my missions. And it can look different for everyone, but it's there almost all of the time. That's something to look out for and to take countermeasures to protect people from whatever they experience. And then the whole us versus them. Also something that I can imagine that some of you already experienced yourselves. So if you are on Mars, in my case, for 4 weeks, and you only communicate with Earth via chat messages, it's very amazing how fast you feel distanced and like you are on a different planet in real or for real, and how fast you start to feel a little bit, I don't know, angry towards Earth. And you're like, okay, they are telling us to finish this experiment, whatever. Don't they know how much we have done already today? They don't know how bad we have it, and they can go and whatever themselves. And and there has been a lot of incidences in spaceflight already. For example, Skylab, the space station that was in orbit before the ISS and the Mir. People mutinied. So there was 3 days of astronauts not communicating with Earth because they were too pressured to work and they didn't want to adhere to that anymore. And if you imagine going away to Mars and being so far away that whatever you decide to do is fine because Earth can't do anything about it. If you decide to just don't do anything for the day, they can jump up and down. They can't make you, right? So the whole losing contact and trying to countermeasure that and to stay close is something that astronauts on the ISS, for example, try to do via video calls with their families, traditions and routines, having parties, celebrating certain things that are also celebrated on Earth, being part of calls to special occasions, stuff like that, bringing their music instruments, all just to stay close to Earth, to stay connected, and to stay human, basically. And there's some more things, but I would like to try to get on a little bit, just giving you a general overview what negative effects on the psyche, all the stress and isolation and all those phenomenon can have. So cognitive abilities can decline. People can have syndromes that are close to clinical depression. They can sleep badly or even not at all. They can have hormonal changes, also affected by the daylight or the missing daylight or the different daylight cycles. They can have personal tension, aggression, or passive, like they can get really like passive and not working anymore. And you can imagine that all of those things are things you don't want to see in astronauts that have to perform and a whole mission depends on them, right? So you see almost always in missions like that, that those factors go up. You have a lot more anger, anxiety, exhaustion, irritability, and social support and group coherence and cognitive abilities and stuff like that go down. And even in the best trained people that are prepared, that know what to expect, you still see those changes. So everything that you design needs to factor in those things. And there's a really good book. It's called Carrying the Fire by Michael Collins. He was the third astronaut that did not land on the moon while Armstrong and Aldrin went down. He was the one piloting the capsule that circled the moon while they were down making history. And he wrote this book about how it felt like to be the only human being on the backside of the moon, knowing that every human being in the universe was on the other side of the moon and he was all alone. And that's an amazing book, also talking about how he felt like coming back after this amazing mission, how difficult it was to get back to normal life after being on the moon. I mean, what else in life can compare to that, right? So that's really a suggestion or a good read that I would recommend. Yeah, and this Earth out of view phenomenon, that people that don't see the Earth anymore and don't feel connected to humankind anymore, that is also expected for people that will be on Mars, where the Earth is way smaller than you see in this picture. I mean, that's the Earth seen from Moon. You can imagine how small it is seen from Mars. And that's going to have an effect on people's psyche, definitely, for sure. And I showed you the pictures of the habitats because I wanted to tell a little bit about my experience, how different my experiences were, depending on habitat design. So in Israel, you can imagine sleeping and living in the small quarter here and then spending the whole day in the laboratory part. You could see your colleagues all day long. It was really difficult to find a quiet spot to have some privacy. We had only our sleeping cabins where we could be like totally alone, and they were made from thin wood, so you could hear anything. So if you wanted to have like a private call that was recorded and sent to your family, the other people had basically to like actively not listen. If they wanted to hear, they could hear. So there was no privacy. And there were very small windows. You had really like you had to stand right in front of them. They were this small and you had to take a look out, but still you felt very isolated. So you really just in the spacesuits going out, you had an idea of your environment. So those 4 weeks felt really isolated and really far away from normal life and from Earth, basically, and from other people. Um, and the effect was that the whole us versus them was very strong. Earth seemed so far away, but the group was really tight, and we had a great time, and we could have spent like months longer. I still am in contact with those people, even though it was several years ago. And it was such an amazing time. We even developed our own language because all of us were from different countries, and everyone like threw in little phrases and stuff, and everyone picked them up. And after 4 weeks, we were talking amongst ourselves. And some people standing around were like, "What was that? I didn't understand." So that was really amazing to see how fast that kind of new traditions and stuff developed. And on the other side, in Armenia, the habitat was so elongated that if you forgot something in the back in the kitchen and you went to the laboratory and you had to go back, that you were really like angry at yourself that you forgot because it was just a hassle to walk back and forth. And we started having walkie-talkies to talk amongst each other because otherwise we would have to scream over the whole length of the building. So if one colleague had an experiment with the suits in one day and the other one was on kitchen and maintenance duty, um, those two people did not see each other for the whole day. And also with the whole big windows, they were quite nice, but I would think not very realistic. But you could always see the outside. You felt much more connected to the outside and not as connected to your team members. And that's just two or three of the small things or the ways how the habitat design influenced how our group worked, how we felt like, how well we worked or slept. So that's something that really needs to be kept in mind, designing habitats and missions. And the same is, of course, true for the space ships that you use to get there and back. Um, and what else you could do, and I put a list of possible solutions for you to pick and use, of course. All of those are already like studied, and there's lots of papers about it. So if you want to take a look, then just find them. Um, that people try to use memories of Earth. I mean, people going to the ISS bring their pictures, for example, or have pictures on their screens. But there's also experiments using VR to have like the whole immersive experience of being on a stream or rain or having the wind on your skin, stuff like that. And yeah, a holodeck like on Enterprise would be quite nice in the future. And it's going to be very important for people to have this memory of Earth and to remember the smells and the sounds and all of that. And again, I already said the missing light or the changed daylight cycles are a problem for human biology and also mood swings and so on. So taking care of the light and designing daylight cycles is also going to be very important. Um, I always ask people what they are going to do with the 37 more minutes that they will have on Mars for every day. So that's something that needs to be kept in mind, how we are going to adapt for that. Um, and then one more thing that we experienced in our missions was that we started to create our own spaces. So, for example, we used some old pillows and mattresses that were lying around from a previous mission and built our own custom-made sofa because there wasn't any chill-out area before we started. So we could have on a black day like a movie night or something, and just lie around and chill a bit. So you need to design also for private time, for social interactions. If you're there for only 4 weeks, you're there to work only anyway. But everything that goes on longer needs private time, needs relaxation, needs socializing for group coherence. And if the space is designed for as little room as possible, wasted and for work only, people will not feel well in this environment. And also, again, as I said already, communication is key. So it would make sense to have easily reachable communication platforms, screens, whatever, throughout a spaceship or a habitat. And also, if you are staying in a small room for a very long time, it's very boring. So if you can have adaptable walls or change the scenery, have wallpaper or screens that can show different things, have different colors, everything that breaks the monotony, that word again, or like makes it less boring would help. Um, then one more thing that astronauts on the ISS always complain about, it's very loud. So sleeping is only possible if you have plugs in the ears, and still it's very annoying. You need to get used to it after a while, but they don't sleep very well. So minimizing sound in sleeping quarters on long-term missions, again, some small things that you don't keep in mind if you're like busy with keeping the weight limits and having enough water and food supply. But no, all the water and food supply in the world doesn't like help if people turn crazy because the psychology wasn't thought about. Um, and I think that's my last point. You saw that we had experiments where we had plants to care for, and that was really nice. Of course, it was nice to have some additional fresh food, but just going there, that were our favorite experiments. We were always like fighting and changing in between ourselves, who was caring for the plants for the day, because that was so nice to have some living things caring for them, seeing them grow. So that will be something that's feasible to have for food, for air supply, but also for caring for something and have some other living entity on your spaceship or in your habitat. And that's one of the pictures from the Artemis 2 mission that I like most, like the whole Moonjoy thing, that shows that the human factor, I mean, you see this environment is not like designed for psychological well-being at all. But they made it. I mean, it was only 10 days. And you could tell how much their group and how they were there for each other and how they cared for each other and looked out for each other, how much that like meant also for people watching, how that was a whole thing going on. And I also had some friends that were like, oh no, I'm so sad this mission is over. My emotional support astronauts are now not on my screen every day anymore. So yeah, that's something that shows very well, in my opinion, that this human factor is maybe not the most important factor, but one of the very important factors. And if you would like to listen to what it sounds like to be on Mars, then this link here is for you. That's one of the rovers where you can listen to the sounds of the wind on Mars if you have not done that yet before. And then there's this nice little documentary about the MID-20 mission in the Negev Desert. There were several movie teams accompanying us, whatever. And that gives you a good idea how that was in the field and what we did there. Yeah, and that concludes everything that I brought to talk about from my side. And I see that there are several questions in the chat that I'm happy to answer. I just want to point out quickly again that if you are interested, you can always check out the Austrian Space Forum's website and just get an idea of what is going on there. And also, as Nicole said, if you have any questions to me after this talk, you can also find me on Instagram, LinkedIn, or send me an email. And the presentation or the recording will be there anyway for you to check it out again. Okay, and then I would stop my screen sharing so I can see you and the questions better.
Could you play the sound on Mars for everyone?
Oh, of course I can. Wait a sec, then I will share again and see if that also shares the. Wait a second. It's here. Um, Wait a sec. I think I will have to do it differently. I just open the.
We will patiently
It's on
wait.
YouTube, so I can maybe also just find the link and put it in the chat.
Okay.
Just a second. I'll have it in a sec. Here we go. And here we go. And I can also open it and share it for everyone to listen to. And it starts at 1 minute. Now I can share this. Ton freigeben. So, okay. And now you should be able to hear. It starts quite low. Hmm. Is it audible for you? Because for me it isn't right now.
No, no, it's not.
No, it's not
Not.
audible.
But
Okay. Wait a sec. Strange. Okay, anyway,
You can drop the link in the chat.
yeah, I put it in the chat. It's the right link. I don't know why it doesn't play the sound right now, but it's around minute or 50 seconds, something in the middle of the video. It's a short video. It plays the sound and it starts quite low, but then it gets louder. So I don't know why it's not working right now, but you can just try it out
Yeah,
yourself.
Zoom is funny like that.
Mhm. I don't know.
Zoom. So I will read the questions, and if any students want to ask their
Mhm.
questions out loud, you may put your hand up. The first question came in right away. Dr. Anika, the moment you put on the suit and stepped out of the habitat for the first time, what did you feel? Was it anything like you had imagined, or was reality completely different?
Yeah, as I tried to answer on that question already before, I didn't really know what to expect. So I wouldn't say it was as I expected, but it was a great feeling. And again, I was aware that I was on Earth, but I felt like very close to what it could be like to set foot on Mars. And having this heavy suit, you have to take very careful steps. Your field of vision is very limited. You don't hear anything from the outside. And yeah, you just like see the red soil and the landscape. And if you really concentrate and get yourself into the feeling, then you're like, oh my God, this is going to be the first person's view and feeling once they set foot on Mars. So yeah, cool to be part of that.
Absolutely wonderful. Another question says, you are a mother, a scientist, and an analog astronaut all at once. How do you explain to your daughters what you do? And do you want them to walk a similar path one day?
Um, that's funny because they are not like I don't know. I would have to ask them if they like what I do or if they think it's cool. I guess mostly they are annoyed that I'm away several times a year. Um, and actually, I don't really like mind is the right word. If they walk a similar path, I want them to find something that they are passionate about and throw themselves into it. And I'm quite sure that they are going to find ways to contribute and to do cool things. And if they are doing that by, I don't know, taking care of other people or studying whatever, or being into space and space science, I don't mind as long as they find something that makes them happy.
Wonderful answer. Wonderful answer. The next question says, do you have experience with different sizes of crews? What number of scientists do you think gives the feeling of community, but also limits the possibility of animosity?
Mhm. So the two missions that I was a crew member for were always with 6 people. But for the world's biggest analog, we had several different crew sizes, like going from I think there were also 1 or 2 crews that were only 1 person, but most were like 2 to 4 people. And very few had more than 4. I think there were several that had 6 people, again, as we are simulating. And I would say that less than 4 is not good because if you have 1 or 2 or 3, it's always like a lot of conflict and it's too less people to have all the skills that you need on such a long mission and so on. And I would think that it's good to have an even number because you can have pairs like going out for EVA and so on. And again, I think it doesn't matter so much if you have like 4 people or 6 people, depending if you can put all the skills you need into those people. It's more a matter of who you select and what skills those people bring to the group. And most space agencies by now select for people that are not like the olden days Mercury fighter pilot alpha people, but they select for people that can lead people, yes, but they can also change and let themselves be led, and that are like very versatile in the sense that they can yeah, accept boredom, but also then be sharp precisely on the spot if needed. And that are quite social. And you need people that like being alone, but that don't mind being close to others. And you can already tell it's very contradictory. most people are either very outgoing and social or very like yeah, more staying by themselves and being fine reading books. But in astronauts, you actually need people that can do both. Yeah, and so you need not to select single people, you need to select a team that works well together. And most people I know working in the field say that if you select a crew that will go to Mars, then for sure you will make them, for example, winter over and stay in Antarctica for 6 months or 9 months before to check out how they will fare in this isolated, very cold, very dark environment. And if they manage that, and if they come out of that as a group and still like work together well, then you can send them to Mars. But the most perfect group that is fine in any exercise on Earth can break, and you don't know beforehand. You can like have an idea who's going to work, but you never know. So yeah, but the original question was crew size. I think either 4 or 6 people will make sense, and that's going to be decided on logistics and consumables and size and of the spacecraft and so on.
Thank you for that very specific answer. It's important for the students to know. The next question I'm shortening because it's a lot of words, but the bottom line is during your mission, how did you manage feelings of nervousness or pressure and maintain your composure in such a high stakes environment?
Um, the answer is we are trained for that. So there's like basic training that we go through for several months, and then a mission-specific training that goes about a year before each mission. And there's so many emergency drills for every situation feasible or thinkable, that you already know how you will react, how your crew will react, who's doing what, where everything is. Every hand knows what to do. So in a real emergency, this kicks in, and I did not experience any big, let's say, moments of nervousness or insecurity or anything. We did have emergencies. In Armenia, I even had to evacuate the habitat once. And I learned the hard way during training that I tend to get very calm under pressure. So then my voice even drops down. They make fun of that, saying that I'm using my therapist's voice in an emergency. So yeah, I get very calm, very quiet, very calming, and very like ones after the other and so on. Um, yeah, and I guess that's also something that you need people for that already have that in them or that train for that. And that's also something that all the astronauts, for example, Christina Koch, explained it quite nice in several of the interviews after Artemis now, that they are trained so well that there's not much space for fear in moments of like emergency or crisis.
Wonderful. That is so good to know. The next question is one of my favorite subjects. Considering that lava tubes on Mars offer ideal protection against space radiation and provide thermal stability, from your perspective as a microbiologist, what specific types of extremophiles or biosignatures do you believe we would have the highest chances of discovering inside them? Furthermore, do you think potential Martian life could have been migrated to into the subsurface over time as a survival strategy?
So yes to all, and also yeah, I think that the best chance is to find bacteria or microbiological life that is close or equal to archaeobacteria on Earth. And I mean, on Earth, if you look in hot springs, deep sea, where the pressure is amazingly high, even like Chernobyl, like reactors, radiation is so high that no other being could survive. But archaeobacteria survive in all of those environments. It's either very acid or very the other way around and so on. So I guess that could be something that also survived on Mars. And yeah, I think that if there's any current life, then most probably it will be underneath the soil or underneath the earth or in the soil and the regolith. And I guess that in the lava tubes, if there's any also like liquid water in the underground or underneath where it gets warmer and so on, that it's probable that we would find something there. And I guess lava tubes or caves is also something where a lot of analogs are done. Because we also did one before I joined the Austrian Space Forum in the Alps, because the suits were tested in ice caves to check for yeah, movability and stuff like that. So yeah, I guess that's something that you would look at on Mars.
Thank you so much. My son Sadek from Syria has a question she would like to ask out loud.
Mhm.
Hello, my name is Maysan Sadek, and I'm from Dix Lab 2 team from Syria. I'm so happy to have the opportunity to ask my question. So my question say, if there's a 15 years old girl watching us right now, and dreaming of something that seems impossible, what would you say to her based on what you actually lived through, not based on what people usually say in moments like this?
Um, I'm not totally sure if I understood your whole question correctly. You were saying that if there would be an all-female crew, or no? Can you
A
repeat that?
15
Sorry.
years old Like if there's a 15 years old girl watching us right now and dreaming about something that maybe it's impossible to achieve. So what will you tell her or say to her, but based on what you actually lived through and go on in your
Yeah,
life?
yeah, okay. Um, Maybe it's something along the same lines I said before to the question about my daughters, who are between 12 and 18 right now, that no matter what background you're from and how privileged you are or not, and what you're going through, if you find things, topics, other people, projects, anything that makes you like glitter on the inside, where you feel like it draws you, that's the right place to put your energy and to try to make an impact, try to learn things about it, and try to dedicate yourself into it. Because whatever you find that makes you glow on the inside, that's also going to be the thing that you're good at and where you like radiate to other people that it's worthwhile to like connect with you and to invest in you and so on. And I also think it's very important to ask others to connect to people and not do things yourself and by yourself, but to like form bands and yeah, find other people that are also passionate about things. And nobody knows what the future brings and if the one goal that people have in their life will work out. But if you enjoy the way going there and if you find things that make you glow, then it doesn't really matter that much if you really achieve the one goal that you set out for. You are going to have a good run going for there. So yeah, I guess that's also what I did in my life. I did not like have this big master plan. I just followed several like opportunities that felt like they drew me to them and they felt like, oh, this is what I would like to do. And then in the end, like looking back, things work together and find like a common, like a red herring thingy. But it didn't like look like that from the start. So yeah, find something that you can imagine doing for the next 2, 3, 4, 5 years and get going, and then opportunities will arise and things will work out somehow, even if it's different than you imagined in the beginning.
Thank you so much. Wonderful question. Hadi, what would you like to ask? Unmute yourself.
Yeah, I'm Hadi Harfoush from the Dixlab 1 team. Thank you very much for the introduction. You answered most of my questions already, but I have this one. From your experience in all the monologues, Mars monologues, and the mental health of astronauts, what do you think the perfect age would be? I mean, in this competition, we're trying to engineer the best Martians. So, what is the best age you would advise someone to go on this mission for, or to train someone at this age?
Hmm. Maybe to step out of their comfort zone a lot and to challenge themselves and to work through challenges and problems, because every time you do something that you thought before that you couldn't, or that you solve something, or that you learn something new about yourself, you grow confidence and you yeah, find yourself in a better way. And then you can like start from a place where you feel very settled and very reflecting about yourself and so on. And I think that all those people going to Mars should go through therapy beforehand to know all their like topics and triggers and so on. So you need really settled and emotionally wise people that can tackle the psychological challenges going to Mars. So you wouldn't send 20-year-olds. You would look for people that have some life experience, that have gone through some challenges, that have faced adversity and overcome it. Does that answer the question or?
Yes, yes, it
Yes,
does.
thank you.
Perfectly. Thank you for the question and the answer. One more question if you have time. Um, you had two missions that you were on. What was the hardest thing you faced in each one?
The first mission, the hardest thing was leaving my family behind because my kids were quite small back then. And the second mission, it was quite challenging being commander and being responsible for all those people and all the expensive equipment and so on, especially when we had some problems. So I was really feeling the relief once my plane landed back home and I could like shed this responsibility. I could really feel myself like breathing again. It was also a quite learning experience, but yeah, that was quite a challenge.
Thank you so much, Dr. Mehlis, for being here and taking extra time to answer as many questions as you could. Feel free to follow along and answer any last questions in the chat if you have time.
I will. Sure.
And to join us for Dr. McKay's presentation, who has now joined us. We all appreciate your time and thank you very much for being here. So, Dr. McKay, if you could, I've got to find you. There's a lot of people on here. Let me know when you're ready, and I will pin you here.
Okay, Nicole, can you
I
hear
can
me?
I can hear you.
Let me remind myself how to use Zoom. Yeah. Do you want to take a 5-minute bio break and start on time at 11?
We certainly may take a 5-minute break, everyone. Thank you so much. We'll be right back.
Right at 11.
Yep, we'll be here. Hello, everyone, and welcome back. Today, we are so lucky to have Dr. Chris McKay, NASA scientist, here to talk about detecting life on Mars. Dr. Chris McKay is a senior planetary scientist and astrobiologist at NASA Ames Research Center and a leading expert in the search for life beyond Earth. His research focuses on the evolution of the solar system, the origin of life, and the possibility of life existing on other worlds. Welcome, Dr. McKay. We are honored to have you here.
Great. Thanks, Nicole. And it's a pleasure to talk to this group. I'm going to focus. I assume you can all see my slides. I will
Yes.
step through the slides. If you have questions as we go along, please let me know. NASA uses Teams. I'm not very good at Zoom, so you might have to interrupt me, Nicole, if I don't realize a question is being asked.
The students will put the questions in the chat as we go, and when you're done, we'll do all the questions at once. How does that sound?
Okay, that's
I'll
fine.
moderate the chat.
Okay, yep. I want to talk about life detection on Mars. And a lot of people talk about life detection on Mars, mostly from the perspective of how to do it, from a science perspective. How to do it, why do we do it, where do we go to look for life, and wouldn't it be exciting to find life on Mars? But I want to talk to you guys. You guys are doing a mission design engineering study competition, I guess. And so I want to talk to you guys about life detection as it relates to astronaut safety and as it relates to what I call return to Earth approval. And these are aspects of life detection that are not science, not astrobiology science. These are very practical implications of life detection for designing a mission to Mars. in which you send astronauts and bring them back to Earth. And I'm very excited to give this talk because you guys working on these designs now are probably going to be involved in missions when they go, which is not soon, but when it happens, it'll be people who are now students who will be doing the designing. So it's important for you guys to understand the concepts here. Okay, the governing document for virtually all activities in space is the Outer Space Treaty. It's not a bad idea to read it through if you're interested in space stuff. Most countries that are involved in space, I think all of them, have signed the Outer Space Treaty. So in the United States, as you look at the bottom of my chart, you'll see the U.S. is a signatory of the treaty. And so that treaty has the force of federal law, and it applies not just to NASA or federal agencies, it applies to everybody, every citizen of the United States, whether they're in the United States or not, is subject to this space treaty. If you are a U.S. citizen and you have a private island in the middle of the Pacific and you build a launch facility there and you launch it to Mars, you are still subject to U.S. rules from the Outer Space Treaty. You're subject to the Outer Space Treaty. And I've run into this kind of thing myself personally. I do a lot of work in Antarctica. Antarctica is not part of the United States, but the U.S. has signed the Antarctic Treaty, which makes actions in Antarctica subject to federal law under that treaty. So if I take a private boat and drive it to Antarctica, go to a penguin colony and slap a penguin, and then go home, I could be arrested under U.S. law for violating the Antarctic Treaty, even if I was not living in the U.S. at the time, even if if my boat wasn't built in the U.S., and even if I didn't return to the U.S., I would have violated U.S. federal law because I was a U.S. citizen. So I say that, I emphasize that because some of you may end up working with companies that have their own agenda and their own resources. And they may want to go do things in space without complying with, say, NASA regulations. And hooray for that. But if they have U.S. entities, they are subject to the Outer Space Treaty. And I think it's similar in other countries. If, Japan's a signatory to the Outer Space Treaty, virtually every country that is in space is a signatory. So it's important, and I'm going to talk about the implications of that for life detection. The key phrase, Article 9, is right here. Avoid the harmful contamination and also adverse changes in the environment of the Earth. So the Outer Space Treaty prevents you from harmfully contaminating any other world, and then it becomes, what do you mean by harmful? And also prevents you from making adverse changes in the environment of the Earth by bringing stuff back. And those then are set in stone in the Outer Space Treaty. Now, that treaty has come into force, for example, in sample returns. When we bring something back to Earth, we have to show due diligence with respect to not causing adverse changes in the environment. And right now, that due diligence is shown through an organization called COSPAR. And COSPAR categorized returns from lifeless, airless worlds as unrestricted. Kind of, okay, this is not a problem. There's no way you're going to cause an adverse change in the environment of the Earth by bringing back a little bit of an asteroid. So Stardust, Genesis, and Hayabusa are all sample returns. They were unrestricted. Mars is restricted. Mars, we are not sure that a sample from Mars would not cause adverse changes in the environment. My bet is it wouldn't, but we're not sure, and the precautionary principle really must apply. So Mars, sample return from Mars by COSPAR rules is restricted. And humans returning from Mars would therefore be restricted because you cannot bring humans back to Earth without bringing some of Mars back with them. either in their lungs or in their boots or in their spacesuits, etc. So this is an interesting point, and I want to show you the implications of it. So the question is, can we assume that there's no life on Mars? And this is not a science question anymore. This is a question that might go in front of a judge who's contemplating a suit that says SpaceX is violating the Outer Space Treaty by doing this and that. And so the judge says, well, is there life on Mars? So this question is not being asked in a scientific context, it's being asked in a legal context. What's the relevant data? There's really two bits of relevant data, and we can have a series of seminars on them. The Viking biology experiments, 1976, 50 years ago this summer, 50 years ago, August. Discovery of perchlorate on Mars in 2007. And then now more recently, the Mars Science Laboratory analysis showing organics on Mars. That could be, but not necessarily are, ultimately of biological origin. Most scientists contend that the reactivity we see in the soil of Mars is chemical and not biological. And I just did a paper on it. The citation is here. It's open access. You can get it. It's only a few pages. But this view is not unanimous, and it certainly would not be considered proof by some high standard. I think the case is scientifically strong, but is it strong enough to risk the Earth's biosphere? The judge might not agree. I would not advise her or him to agree. I don't think the scientific case for chemistry as the explanation of the Viking results is strong enough to stand up beyond a shadow of a doubt in a case with respect to the Outer Space Treaty. And that's reflected by the fact that both NASA and COSPAR consider sample return from Mars as a potential biological risk, that it must be treated as a potential biological risk. And I conclude that it is unlikely that public opinion or legal procedures will support an assumption of no life on Mars, even if the bulk of the scientific community thinks that that's the case. The standard of proof for science is very different than the standard of proof in a legal procedure, especially when there's risk associated with the outcome of that legal procedure, right? And so astronaut return from Mars is subject to, I think, a different standard of evidence than, say, a scientific mission to go search for life. Are we likely to find something or not? Okay, I'll quickly tell you what Viking found. This is timely because now that the 50th anniversary is coming up in a few months, I'm being inundated by reporters and people writing articles about Viking after 50 years. What do we know? Where do we go? Why haven't we done more like this? And so on. It had 3 biology experiments to detect life, and it had a gas chromatograph mass spec to detect organics. This is a diagram of the biology experiments. The essential point of all 3 of these experiments is take dirt, put it in a jar, and try to see if anything is growing. Try to see if anything is alive, one, and if it's alive, can it grow? Can it grow if we shine a light on it? Can it grow if we add soup? Can we grow if we add soup plus some gases? So keep in mind that Vikings searched for things that were alive and that which would grow in the jar. And that's a very primitive way to do a search for life. Well, that's because it was 50 years ago. Nowadays, we would not search for life this way. We would search for life by looking at the biomolecules that the life forms are made out of. And the good thing about that is, in that case, the search for life would include life that is dead. Imagine that something just died, roadkill on the highway. If you picked up that roadkill, let's say it was a dead squirrel, I was going to say a dead cat, but I'm fond of cats, so I'll use a dead squirrel as the example. A dead squirrel. You could analyze that dead squirrel, even though it's not alive, you could tell that it was alive because it would have characteristic amino acids and DNA and all these molecules indicative of life, even though it would not respond in any way to any growth experiment. And so we've gone beyond the Viking experiments and how we would search for life. Um, it was the best that they could do at the time, but we don't do life detection that way. Okay, this slide just repeats what I said. Uh, Viking tried to grow soil organisms. We know that that doesn't work on Earth. This is not the way to search for life. Now we do it by searching for molecules. What were the results from Viking? All of the experiments did something. There was some kind of reactivity. Stuff was happening on Mars. A key factor in the discussion at the time was that the GCMS did not detect organics. And that was a puzzle. How could you have life without organics? The LR experiment in particular, labeled release experiment, acted just the way it should have acted if there was life. But the lack of organics made most people, including myself, conclude that there's no chance that the explanation was biological. It was some kind of chemistry. Chemistry can duplicate what life does. If you think of an organism can consume organics and produce CO2, well, you can consume organics by putting them in bleach. That will also produce CO2. So basically, to simplify it, after the Viking mission, the conclusion was there's not life on Mars, there's bleach on Mars, or some oxidant. Then Phoenix went to Mars in 2008, landed in the polar regions, and it made a very important, very surprise discovery, important for mission design. I'm not going to go into the details on that because I'm focusing on life, but it's important for mission design. First of all, it confirmed that there was ground ice, but we knew that there was going to be ground ice. That's why we sent the mission to the polar regions. But it discovered something that was completely unexpected. I call it a black swan event. Perchlorate, half weight percent perchlorate in the soil. That was a shocker. We find perchlorate in deserts on Earth, and it's parts per million. And it's a big problem. If it's parts per million, that's toxic, cause thyroid condition in groundwater when people drink the groundwater. But this is 0.5%. This is thousands of times more perchlorate on Mars than on Earth. Completely unexpected. It was discovered through an instrument that was designed to detect nitrates, and it ended up detecting perchlorates. That's an issue because, as I just said, perchlorates are toxic for humans. It's not acutely toxic. It's not like arsenic. You're going to fall over dead a few minutes later, but it creates a condition in the thyroid, which is very bad. And for that reason, perchlorate is regulated as a hazard in groundwater. It's very soluble and it gets into groundwater, and the groundwater you drink is being tested for things like perchlorate, and there's limits in the United States set by EPA on how much perchlorate can be in the groundwater. And that limit is parts per billion. This is half a weight percent. Okay, what is perchlorate? It's chlorine molecule attached to 4 oxygen. It is the most oxidized form of chlorine. You may be familiar with it from rocket fuel. If you do model rockets, in a model rocket, there's the fuel and the oxidizer. The oxidizer in model rockets is perchlorate because when it's heated up, it decomposes to very reactive oxygen. Perchlorates decompose and release oxygen when heated to about 350 degrees. This is why it's used in rockets. The shuttle solid rocket boosters are packed with perchlorate. It's stable at room temperature, but once you light it at 350 degrees, it decomposes, becomes a very strong oxidizer, reacts with the fuel, creates a fire, and that propagates up the solid rocket booster. It's also a strong antifreeze. It's also edible for microorganisms. There's a lot of microorganisms that use perchlorate, analogous to the way that we humans use oxygen, which is to oxidize food, right? We humans take in organic material, ideally in the form of chocolate, and we breathe in oxygen, and those react, and that produces energy, which we use for metabolism. There are microorganisms that also eat chocolate and react it with perchlorate, and that gives them energy. Okay, organics and life on Mars. What's the conclusion? Viking did not detect organics, but we think that that was due to the confounding effect of perchlorate. And at the same time, perchlorate becomes the most compelling explanation for the reactivity that's seen, because perchlorate, bombarded by cosmic rays on Mars, produces very reactive bleach-like compounds. And Curiosity in 2013 confirmed that perchlorate was the explanation. So we argue in this paper that I mentioned before that perchlorate provide and its radiolysis products to provide the most straightforward explanation for the Viking results. There's no need to postulate life forms on Mars to account for the Viking results. That's a scientific conclusion. Would I stand up in a court and say, we're certain there's no life on Mars? No, that's a very different conclusion than what we're drawing. We're drawing a very limited conclusion about a very limited experiment on Mars. Being able to say a blanket statement that there's no life on Mars is beyond me. And I'm going over this point over and over because it will come up this summer as people talk about Viking, and it will come up as people talk about bringing samples back from Earth, either the US or China bringing samples back. We have to worry about that. How do we apply the Outer Space Treaty? And it will come up if you design a base on Mars and you have to protect your astronauts from perchlorate, and you have to protect your astronauts from life if it's there, right? So with respect to life, I argue that we need to do life detection for human return, not for science, although I'd love to do it for science. It's needed for human return. So we need to plan on, if you are designing a Mars mission, then I ask you to plan on in situ life detection to demonstrate lack of biology at the human landing site for compliance with the Outer Space Treaty. Right? So imagine you're a space billionaire. You don't know what to do with your money, so you build a mission to go to Mars and you launch it from your private island in the Pacific Ocean. Goes to Mars. The astronauts have a good time. They're coming back home. Somebody files a lawsuit to prevent them from returning to Earth on the grounds of the Outer Space Treaty. So then your job as a scientist and engineer that designed the mission is to stand up in front of a judge and say that you have done due diligence to confirm that there's no risk of life contamination on those returning astronauts. And that's why you need in situ life detection to demonstrate lack of biology. So here when I do a life detection mission as a science mission, I want to find life. Here, your goal is to show that there is no life so that the astronauts can come home. Because if you do life detection on a human mission and you find there's Mars life, now you're really in a bind. You're standing on Mars, you found evidence of life. Are they going to let you come back to Earth? I think the short answer to that is no. You're standing on Mars and you want to come back to Earth, so you want to prove to the satisfaction of non-scientists and legal experts on Earth that you're coming back without anything that's alive. Okay, so we propose a payload adapted from the Mars Icebreaker mission, which is a mission to search for life as a science goal. We would say you need to get samples from the surface and from the subsurface. And here's the instruments we would propose to put on there, the same instruments we'd put on the mission to search for life. And you say, okay, what would a lack of result be? At what point would you say, look, the instruments work, we didn't find anything. This is a pretty good indication there's no life there. This represents due diligence under a reasonableness standard in terms of the legal requirements of the Outer Space Treaty. A reasonable no life result would be to show amino acids and lipids are present, but only those amino acids and lipids that would be expected from meteorites falling on the surface, not the distinctly different acids and amino acids and lipids that would be associated with biology. And here is the science behind that. This graph here shows what you'd find if you're analyzing meteorites. This graph shows what you find when you analyze something that's alive, right? It's clearly different. So our mission, Icebreaker, was designed to make these measurements, hoping that we would, A, see meteorite stuff, that's got to be there, but also see this pattern and be able to say, this is not meteorite stuff, this is something alive. And in this application of return to Earth, you want to say, we see this, check, everything's working. We don't see this at the level of detection, right? Now, I point out that life that's not Earth life will also show a pattern that's different from the meteorites, but it may be a different pattern than Earth life, right? So we can detect not just, so we have three cases here, not life, that looks like this, Earth life, and what I call exobiotic life. So this chart is biotic, abiotic, biotic, and exobiotic. And this set of tests would recognize the difference between them. Now, I'm not going to go into this in a lot of detail in a short talk. I've given you the references here, and I'm happy to send these papers to any of you who wish to look at them. So from a science point of view, it's interesting to search for life as we know it, biotic life, and also to search for exobiotic life. My dream is to find evidence for life on Mars, check, and for that evidence to indicate that the life is not life as we know it on Earth. Similar, but not the same. That would be really cool. But that's the worst case scenario for astronaut return. If you land on Mars, you're hoping, and you want to come home, you're hoping for this case, nothing but abiotic. If you find biotic, you say, okay, well, maybe that's stuff that's spilled out of our spacecraft. Maybe that's our waste. And if you look at it closely, you can tell. But if you find exobiotic, now you're in trouble. Who's going to let you come home when you got exobiotic organisms on you? Nobody, not me, right? So the interest is flipped around when you're using this as a return to Earth gate versus when you're doing scientific exploration. Your desired outcome is flipped around, but the tools are the same. The instruments are the same. You do the same tests, in my opinion. Okay, this just is a graphical explanation of that. It was worked up in a paper in which I did the difference between biology, exobiology, and abiology, and how you'd see them in the molecular distribution. And there have been more refined papers along these lines since 2004 when I wrote this. Okay, so the concept here is I call biosafe on Mars. Concept for life detection as a separate mission in a deployed payload. Collect samples, drill a rover, do a highly sensitive detection of amino acids, lipid, and larger molecules. And success in this case is a lack of detecting life and detecting only meteoritic amino acids and lipids as adequate evidence of biological safety. Okay, I want to now pivot a little bit as I wrap up and open up for questions. A lot of people say, well, you send humans to Mars, you're going to ruin the search for life. If you send humans, it's all over. There's no point in searching for life because once the first human opens the door, the whole planet is contaminated beyond utility. And that's just bunk. There's no basis in field microbiology, which is something I've been doing for so long I don't remember, like 50 years. There's no basis for thinking that a couple people are going to contaminate an entire planet. I did a calculation that if you took an entire starship, the entire payload of Starship, and smashed it on the surface of Mars full of dead squirrels and spread them evenly all over the planet, the level of organic contamination would be undetectable. Planets are big things. Humans are small, our spaceships are small. And we can recognize contamination from humans. That was this whole point of this chart. We know what we look like, right? And in contrast, humans bring a lot of equipment with them, and they can do things that our little rovers and landers can't do. Like they're likely to have big drills, drill deep. They want to get water, they're going to drill deep. So just the programmatic and equipment load that goes in support of humans probably will advance life detection enormously compared to what we're doing with these little missions we do now. And field studies on Earth, especially deep drilling, provide an example, analog. We've been practicing deep drilling in Antarctica. We want to do it on Mars, and we've learned how to do it cleanly so that the sample we bring up is separated from us. It's aseptic drilling. As the drill goes down, it's sterilized. As it comes up, it's contained. We've been practicing that. We think we know how to do it. More practice is always better, of course. That's what I tell my piano students. Okay, that's the end of my formal talk. Half an hour was my target. I'm going to now end the sharing and hopefully have 15 to 20 minutes for discussion. Nicole, does that work on the schedule here?
Absolutely perfect. Our next speaker is due in 12 minutes, so I'm sure
Oh.
we have a couple minute lead, 12 or 15,
Perfect.
somewhere around there.
That's fine. Okay, can you moderate,
Yes,
Nicole?
sir. I certainly will. I'm ready.
Thank you.
And I have a question for you, Dr. McKay, as always.
Great.
How can we be sure the astronauts on Mars will be honest if they find life on Mars, if they want to come back home and not die on Mars? Sounds like a
That's a good question.
screenplay. Sounds like a screenplay.
Yeah. In real life, all astronauts are honest. All scientists are honest. It's only in the movies that they're bad and misbehave. So let's count on that.
Okay.
But I don't know the answer to that. I think that's an important question. It's not a question I can help answer, but maybe some of you guys who have experience with human factors in astronaut selection and the previous talk, as example, what people do in isolated, confined environments, that will come into play. Being a scientist, there is a culture of honesty that's sort of hammered into us with a heavy sledge. But then, nothing we do, our life doesn't depend on it, I'm not going to get stuck in Antarctica because of some result I find that prevents me from coming back to California.
Right.
So it's an interesting question.
Well, I'll talk to Andy Weir about it. Maybe he'll make a book about it. Okay,
Yeah.
thank you. Hattie, would you like to ask your question?
Yes, I don't know if I'm allowed. I actually have two questions.
Okay. Fire away.
Yeah, I'm Hadi Harfouch from the Dex Lab. Thank you very much. It's an honor to meet you. My first question is, one sec. Yeah, based on your experience working in the Phoenix, Lander, and all the experiments in Antarctica, where do you draw the line between instruments that we can take to Mars that offer scientific value and instruments that might not offer the same benefit or whose payload is just too much? It exceeds their scientific value.
Well, that's a very hard question because usually we have to decide that on the very limited capabilities of our spacecraft and landers. And I go to the engineers and say, I want to do this and this and this and this and this, and I want to drill 10 meters. And they just laugh and they say, look, we can drill 1 meter and we have enough mass capability to land about 10 kilograms on Mars. Go figure out what you can do with that. So it's always with robotic missions, it's always capability limited, what we can put on Mars, what we can do on Mars, which is one reason why I was saying that human exploration, which is always of a scale much, much larger, there will not be such capability limitations. So we are constantly trying to struggle with the question you're asking. What instruments can we put? This one is too, we'd really like to fly this one, but it's too big. We fly that one. So it's tough, and there's no general answer. Every mission is kind of specific, but if you get involved in flight missions, you'll face the same frustration. Um, how do I get everything I want to do on here, and what instruments weigh? It's just kind of it's a whole aspect of doing science and space that I didn't appreciate at all when I was just getting into it. And it's mostly what you spend your time on.
Okay, next question. How can you clean regolith from your suits and gear if it's toxic?
You can't clean regolith from suits. At least we don't. Uh, think of Apollo on the moon, and they came back. Suits were filthy. It's going to be dust. In theory, it's possible to clean. In practice, it's not. And then how do you prove that it's clean? It's a very difficult question. You could try to take a purely engineering approach to dust on Mars and say, I won't let the astronauts come in contact with dust. And when they leave, we will make sure they leave all the Mars dust behind. I think that's going to be very, very hard to do. Way more expensive than doing a life detection test right there on
Right.
the surface.
Yeah. Yeah, it's very tiny, that dust.
Yes,
A
yes. And it
question
gets in your
from,
nose.
yeah, everywhere, and all the gears of everything. Mohammed, your question?
Hello, Mrs. Nicole. Hello, Doctor. Thanks a lot about this brilliant and important lecture. I was be today so late, so I have two simple questions, please, if you can. Okay, the first question is, what are the disadvantages of relying on peak time or long duration simulations? And is it possible to integrate all tests and computer-aided simulations into one higher resolution systems? Okay, the second question is, how can the material extraction region be directly separated from the analysis region? Thanks a lot.
Uh, Let me answer your second question because that's an area that I've worked in. Uh, we're taking a sample and we're taking a sample here and we want to analyze it over there. And that's also that's actually challenging on Earth too. We drill, for example, in Antarctica, we drill through ice-covered lakes. We sample an anaerobic high salt layer, and we want to see what kind of organisms are living there, right? That means we have to first sterilize the drill that goes down in the ice, and then take the sample and somehow contain it so it doesn't come into interaction with oxygen because it's from an anaerobic zone, and get it over to the lab and then contain it in a glove box in the lab. Once you're in the lab, once you've got it in a lab in a containment facility, we know how to work with it. But the step from it's in the environment to now it's in the lab is a very hard step. And that's, I think, the essence of your question. It's a very hard step. It's hard here on Earth, and it's going to be hard doing it on Mars because often the lab on Mars is on Earth. You got to bring the sample all the way back. Or if the lab's on Mars, you still have to transfer it cleanly. I don't have a general answer. I just say it's a hard problem, and you have to know how to isolate and transport at the same time.
And the bottom line, oh, go ahead.
Your first question about simulations, I think simulations play an important role because when you go to Mars, you want to try to do as much as you can in advance to be prepared for it. I think that was the gist of the question. And so I think that, and of course, doing simulations on Earth, both with respect to people and crew, with respect to equipment, with respect to rovers, and so on, has to all be put together into a big overall mission plan. And still, things will go wrong, and you have to be prepared to deal with it. And people will go wrong. Just as a side point, and a follow-up to the previous talk, in my experience in Antarctica, which is many, many years, many, many trips, the limiting factor in our productivity in Antarctica was not equipment, was not transportation, was motivation. People's motivation and determination and ability to work together was the factor that determined how productive we were, right? Very always, very often, really always, the human factor was the limiting factor.
And we need more critical thinking and creativity to solve the problems you're talking about because these
Yeah.
questions from these students are incredible. This group of students is highly motivated and inspired, and the questions are hard questions, and that's what we have to
Yep.
work on
Yep.
this
Yep.
project.
Yep.
All right, last question for Dr. McKay because our next speaker is waiting. Mason.
Hello, I'm Mehlis from Dix Lab 2 from Syria. I'm so happy to have the opportunity to ask my question. So my question is, you spent more than 30 years searching for what you call a second genesis of life on Mars. And in one of your interviews, you said openly that you don't expect to see the answer in your lifetime. How do you keep going with this work while carrying the feeling with you every single day?
Well, I don't remember saying I don't expect to see the answer in my lifetime. I try to extend my lifetime. I stopped smoking. I'm going running every day. I want to be there when we find a second Genesis. Uh, but but really, it's a long question, and I'd like to see evidence of life somewhere else. But I realize that it may happen. It may not even be in our solar system. We may have to wait till we go beyond further. In the meantime, we search analogs. In Syria, northern Syria, in the deserts there, we did an expedition there some years ago with people from the university. That's a very good place to find analogs. And particularly interesting, I don't know if you know the site, there's a place in the northern desert which is completely lichen covered. All the volcanic rocks are covered with white. It looks like they've been spray painted white, and it's lichens. And it's one of the few places in the world where you can see microbial life from outer space. Looking down with a satellite, you can see the lichen fields of the deserts of northern Syria. Just a little fun fact to know and tell. Okay, Nicole, we should probably wrap up so you can get to the next speaker.
Yes, and if you would like, if you have time, can I email you the rest of the questions in the chat
Sure,
and I'll send
sure.
them to the students. Thank you,
Okay.
Dr. McKay. It's been an honor to have you here today.
Yeah, thanks for what you're doing, Nicole, and good luck to all you guys.
Thank you. Be well. Okay, everyone, I will unpin you, Dr. McKay, and let's find Dr. White is here somewhere, but there's a lot of wonderful. Oh, there you are. Hi. I have too many people on the screen. Which is a good thing, right? All these wonderful students. Hello, Dr. White. I will give your intro and then you should, let me make sure you're a co-host so you can share your screen. See if you can share. Are you going to share a screen?
I will be.
Okay, let me give your bio. Frank White is an educator, space philosopher, and communications consultant. He has authored or co-authored numerous books on topics ranging from space exploration to climate change to artificial intelligence, which you all know you're not going to use on this project. His best known work is The Overview Effect, Space Exploration and Human Evolution. Welcome, Dr. White.
Thank you. Nicole, how much time do I have? I just want to be sure I stay within the time.
30 minutes and then about 10 minutes for questions
Okay.
if you can.
Very, very good. Okay, hi everybody. It's great to be with you and also quite an honor to follow somebody like Chris McKay. He's a legend in the field of Martian studies. So I'm very, very happy to be with you today. And I just should tell you in the beginning, I'm not going to talk about Mars until the end. My work is mostly about the Earth. However, it relates to Mars. And if you're going to be doing a design study or a plan for Mars, you need to think about human psychology. So I'm going to talk about the overview effect as part of human psychology. How does that relate to Mars? And I will get to it. Don't worry. I will get there. So here we go. Let's see. I'd have to be sure I'm sharing sound as well. Okay. All right. Okay. But I don't
Looks
want
beautiful. Looks beautiful.
don't want to start there though. That's the end. All right. So what I'd like to talk with you about is the overview effect and the Earth out of sight phenomenon. And I'm going to start with a term that you may or may not have heard of. It's a paradigm. What is a paradigm? And what's important here is that a paradigm is a way of thinking, it's a way of seeing the world, and it represents, as the slide shows, a set of shared values, beliefs, and techniques within a discipline. And once a paradigm becomes really dominant, it's very hard to replace it. Very, very difficult. So here is a view of the solar system that was the dominant paradigm for thousands of years for humanity. This is called the geocentric view of the solar system. If you look at it carefully, here's the Earth, and it's called Terra Immobilis. And it means unmoving Earth. And way out here is Sphera Martis. That's Mars. And so Mars is out there and Earth is here, and all the planets are moving around the Earth, and the sun is moving around the Earth. Today, we mostly have a heliocentric model or paradigm, and that is based on the idea that the sun is at the center of the solar system. The geocentric model makes a lot of sense because our senses, our eyes and ears and body, tell us that we're on an immovable platform, doesn't it? And the heavens are revolving above us. We're the center of the universe, center of the solar system. And the heliocentric model is conceptual. It's an idea. And we don't feel it, right? So there is a problem with the geocentric model, and it has to do with Mars in particular, which is with the Earth at the center of the solar system. It appeared that certain planets, in particular Mars, got the astronomers' attention. Certain planets went backwards. How could that be? How could the planet go backward and then forward? So they invented something called the epicycle. They said, oh, it goes up like this, and then it comes back down, and then it goes forward again. The heliocentric model solved the problem because it said the Earth is not unmoving, it is moving. And there are times when it's ahead of the other planets like Mars, and there are times when it's behind the other planets like Mars. And it appears that the other planet is moving. A heliocentric view was proposed by a Greek philosopher 300 years BCE. His name was Anaximander. Hard name to say. 300 years before Christ, if you're looking at the Christian calendar, 300 years before the Common Era. It was not until the 1400s that the heliocentric view of the solar system was really, really challenged. So, why did it take so long? Well, paradigms die hard. People get wedded to their paradigms, and the Catholic Church in Europe in particular was very strongly wedded to the idea of the sun at the center, the earth at the center, because their idea was God created the earth as a super special place, humanity a super special species, and they were pretty rough with people who disagreed. And Copernicus was an astronomer who really thought the heliocentric model was better. He wrote a book about it, Revolutionibus, Revolution of the Spheres, I think it was called. And our word revolution actually comes from his work. He did not publish it until he was on his deathbed because he was afraid of the church. You know, he was right. There was another guy named Giordano Bruno who accepted Copernicus's ideas, and he was burned at the stake. He was killed. Galileo accepted these ideas, and he was put under house arrest for many years. Today, the heliocentric model dominates, but it took a long time for this to happen. So I am proposing a new paradigm, and Mars fits into it actually, and that's called the overview effect. So how did this come about? Well, I was flying cross country, looking down at the Earth, and I was imagining what it would be like to live off of the Earth permanently. And I was working with an organization called Space Studies Institute. They imagined people living throughout the solar system. And I wondered, what would it be like to live permanently off the Earth and see the Earth in the sky like it is behind me every day? And I just had an insight. I would see the Earth as a whole system, no borders, no boundaries, one whole connected system. I would experience the overview effect. And there are no people living off of the Earth permanently today, and there were none in 1984. So I started interviewing astronauts to find out if they had had any experience like I was talking about. And I got confirmation. Now, I did not interview Yuri Gagarin, but he was the first person to experience the overview effect before it had a name. And he flew in April of 1961 for the Soviet Union. And it was quite a shock to Americans because we were divided into countries. We're in a Cold War between the United States and the Soviet Union. And we didn't say, hooray, humanity has gone into outer space. We said, oh no, a Russian has gone into outer space. Now, we've made some progress over time. That progress has reached the point where there's a party every year put on by a friend of mine, Loretta Whitesides, and it's called Yuri's Night. and people get together and celebrate Yuri Gagarin, people from everywhere, all over the world. And so we've progressed to a more global view. Yuri Gagarin didn't have the term overview effect, but a lot of what he said sounded very much like the overview effect. He said, orbiting Earth in the spaceship, I saw how beautiful our planet is. People, let us preserve and increase this beauty, not destroy it. And he said, looking at the Earth from afar, it is too small for conflict, but large enough for cooperation. So he saw what I was thinking long before I started writing about it. He had that experience that I was talking about. And since then, I've interviewed over 50 people who've gone into space. And there are certain themes like no borders, no boundaries. I don't see any. The Earth is incredibly beautiful. They all comment on the thin, thin blue line of the atmosphere that protects us from outer space. And they realize our civilization on Earth is pretty fragile. And they often say we're all in this together, and they mean beyond the boundaries and borders of countries, humans are more alike than different, and we need to start working together. Now, I always like to let the astronauts speak for themselves. So here is astronaut Mike Foreman, a US astronaut. He flew long after Yuri Gagarin, and I interviewed him in 2019. And here's what he had to say about his experience.
We cannot hear any volume on that.
Okay.
There's a special setting on Zoom, and I don't know what it is that is preventing the volume to play.
Yeah,
Oh,
hold
here it
on.
goes. Here it goes.
Are you hearing it now?
Down
Yeah,
to
yeah.
zero, and you feel like you're just in a car wreck because the solid rocket boosters light off and they give you a kick in the backside like you were just rear-ended at a stop sign, literally, and launch you into space. And 8.5 minutes later, you're there and float out of your seat and start taking in those views, which I can't describe. That's one thing I wish I was better at. It was actually describing that experience of being weightless or experiencing the views of the Earth. It's just, so incredible. I was there for 2 space shuttle missions, so I was never there for more than 16 days at a time. But every time I had a spare minute, I would go to a window, take a look out. Spacewalks always seem to be very busy and task focused events where I got to do this and I got to move over here and do this. And rarely did you have a minute where you could just say, just take a minute and enjoy the view. But, there were those minutes every once in a while. And the view from outside the spacecraft, with that full panoramic vision through your helmet visor was just incredible. So I always kid those astronauts that don't do the spacewalks. I said the view from inside here through this flat window is pretty good. View from outside is just amazing. The colors of blue that you've never even seen before, the shades and hues of blue, and you see that fine, thin atmosphere that protects us. It's just almost overwhelming when you first see it. I think if you're not a conservationist before you go to space, you're at least partly a conservationist when you come back, because when you see how thin that atmosphere is, that protective layer that we have here, it allows us to walk around like without a spacesuit on down here, and breathe the air. You think, wow, we really have to take care of this because it does look so fragile from space. I think if we could get all 6 billion people or however many we have now on the planet, to see that view for just a few minutes, I think the whole planet would change.
So I think you can hear many years after Yuri Gagarin flew, and even though Mike Foreman is American and Yuri Gagarin was Russian, a lot of the same themes: beauty, we need to cooperate. If everybody could have the experience, the the planet would be different. So I think the overview effect is a universal phenomenon. And as we move further out, we have even more powerful impact. And one thing I learned in doing this research is that going into outer space changes the psychology of humans. So low Earth orbit is a change. Moon is a change. Mars will be a change in human psychology. In 1968, Apollo 8 traveled to the moon. They didn't land, but they captured this image that's right behind me called Earthrise. It was a great surprise because they weren't really supposed to go to the moon. It was supposed to be an orbital mission, but it really gave us a sense of who we are and where we are in the universe. And we are on a spaceship. The Earth is a spaceship. We are the astronauts. We are the crew. And you look at this beautiful blue planet full of life, and then you look down, you see the moon. It's a very harsh environment, as far as we can tell, no life. And you look outward, you see the universe. Nowhere in the universe that we know of that we can get to, including Mars, where we can live without special equipment. We evolved humans to live on Earth. Is there any way to summarize briefly? So, a lot of the question here about a new paradigm is it valid to talk about the Earth and space being different? We are in space, really. We are always been in space. We're not really going into space. What happens is, as an astronaut, you go off of the planet and you see we are in space. You see that the heliocentric paradigm is correct. We are on a planet moving around the sun. Mars is another planet moving around the sun. Venus is a planet moving around the sun. And it's all part of the same heliocentric system. This is an interview with Sarah Sabri. Sarah is the first Egyptian person to become an astronaut. She flew on Blue Origin under the auspices of Space for Humanity, of which I'm an advisor. I interviewed her before her flight and after, and in this interview, I'm asking what changed as a result of your flight. What you think changed?
Yeah, I think so. I think one of the biggest things for me was the lack of separation between Earth and space. And because we've always used the terms space and Earth kind of separate from each other. And we always thought, okay, we're doing things on Earth here, and then like there are certain things that are going to be done for space. But for me, when I was up there, I realized that there's no actual separation between the two. The Earth is just a continuation of it, and we're just a part of this much bigger thing. And that to me, when that clicked, it just like was, oh, like it makes sense why we're doing what we're doing. It makes sense for us to need to explore it. It makes sense for us to need to understand more of it because it is us. We are it. And that was the biggest thing for me. And I think I was more on the side of looking towards the outside. Like I felt this connection between Earth and space more than anything. It just felt so part of one another that it was so hard. It's so hard for me to separate the two now. It's just I think that was the most overwhelming feeling that I felt from this whole experience.
So what Sarah's talking about is when she flew and she had a very brief suborbital hop, she started to see Earth and space as part of a continuum, not as separate things. And I think that begins to give us a new look at Earth, but also at Mars. Both Earth and Mars are in space and have always been in space. Recently, all of us saw Artemis go to the moon. We had not been to the moon since 1968, and Artemis 2 was a lot like Apollo 8. There were terrible things happening on the Earth and beautiful things happening on the moon. Chaos on the surface, harmony above. Artemis engaged people much more deeply, though, and people really got involved in it. A lot of people wondered, would they take an iconic photograph like Earthrise? And they did. This is Earthset. And it's fascinating. You see again the lifeless moon in the foreground, the beautiful Earth, and then the dark and somewhat foreboding or forbidding universe behind. And the astronauts had a wonderful time. They really espoused what I call overview thinking. And they came up with a new term called moonjoy.
Everything, the training, but in three dimension and absolutely unbelievable. This is incredible. Happy Moonjoy. I definitely see all of the basin of Oriental, easily all is you. This is so awesome. We look like we're smiling at you, like a little Cheshire cat. I thought we just caught an ActiWatch sync. If I had my own, I'd sync it with you. Breaking news, at this time, you are go for all types of uses of the toilet. And the crew rejoices. Thank you. We caught a view of Earth in window one, and now we're completely distracted for a little bit.
To me, is a great, example of why we go and do these missions. If you can't take love to the stars, then what are we doing? Like, why would we even go?
I think that's very a beautiful sentiment. If we can't take love to the stars, what are we doing? And so this overview thinking, hopefully, is something that will carry us forward as we explore and as we leave the Earth and go to Mars. Okay.
That's everything.
And here's a final thought when the crew came back about their experiences.
We were certainly hooked on this mission, but when we came home, we were shocked at the global outpouring of support, of pride, of ownership of this mission. And really, I think at the beginning, that's what the four of us wanted. We wanted to go out and try to do something that would bring the world together, to unite the world.
When my husband looked me in the eye on that video call and said, "No, really, you've made a difference," it brought tears to my eyes. And I said, that's all we ever wanted. Yep. And I can tell you that the difference now is when we come before you now, we've done this together. We took your hearts with us and your hearts lifted our hearts.
What I've come to realize is we did what we said we were going to do. Yep. And now we've got to step out and just face that reality. And so that's a great thing.
All we saw was a camera. We didn't have that connection with you. We lost that connection with Earth by and large. And so we just leaned into what we had. We leaned into each other and mission control, which is really all we had in our families a couple times. But we did that because we had been lifted up and supported to just go up there and be ourselves and just do our job. And we went into it thinking, it's not going to be perfect, but it's going to be good enough. seems like it was good enough.
We were certainly.
So this is overview thinking versus surface thinking. I won't read all of it, but Victor Glover said, this is an opportunity to remember who we are, where we are, that we're all the same thing, and that we have to get through this together. And Christina Cook said, a crew is in it all the time. No matter what, a crew is inescapably, beautifully linked. Planet Earth, you are a crew. So I see overview thinking beginning to take over from surface thinking. Um, Surface thinking sees the world divided into countries. Uh, the globe has countries that are yellow, pink, and green. There's a focus on division and conflict and difference. There's not an understanding that everything is connected. And this is the real world. This is the world that has reality to it, where there is unity, oneness, and cooperation, and the understanding that we are crew of Spaceship Earth. Well, what about Mars? I finally got to Mars. So, what happens to the psychology of humans when we leave for Mars and we start designing space habitats on Mars? Distance is important. So, low Earth orbit is 240 miles from Earth, and you can still see Earth. It really dominates your view. The moon is 240,000 miles from Earth. But again, look behind me, you can still see continents, oceans, and clouds. At its closest approach to us, Mars is millions of miles away. I think it's 35 million miles from us. Now, any crew that leaves the Earth to go to Mars is going to experience the overview effect. They will see the Earth from a distance. But a lot of people have asked me, what is the overview effect like on Mars? And it's not the same. It's really going to be different. And a new question arises. What happens to human psychology when the Earth is out of sight? What happens when you really can't see the Earth in the same way? And in writing my book on the topic, I said, this is really different from the overview effect related to Earth, and I called it the Copernican perspective, going all the way back to Copernicus, who came up with the heliocentric or reinforced the heliocentric view. Here's a little film of the Mars rover as it looks at Earth from the surface of Mars. Start at the beginning. I'm just going to move on for the sake of time, but I think you get the point here. The question that I want to raise for you is, if you're going to design a human community on Mars, yes, as Chris McKay pointed out, you need to think about, is there life there? And if there is, what do you do about it? But also you need to think about, what is the mentality of people and how do people stay balanced when they can't see their home planet the way they're used to? Do they start to have a new mentality that relates more to Mars and to the solar system? Also, what is it like to know you can't go back to the Earth? Because you probably can't, or it's probably going to be difficult because you're going to grow up in a lower gravity system. It's going to be really hard to be on Earth. It's going to be hard to move around. You're not going to be accustomed to the sunlight, which is going to be much harsher to you. You're going to be used to a very different planet. And this is called the Earth out of view phenomenon. It has been, or Earth out of sight, it's been studied by many people, including a psychiatrist named Nick Canis. And I really believe, Chris said, if you're going to put a human community on Mars, you need to find out if there's life there, even primitive life. Well, I think in addition to that, you need to figure out what kind of people are going to be okay going to Mars. And just to take it one step further, and then I'll leave it there, what's it going to be like to be born on Mars? What is your connection to Earth going to be? You've actually never experienced the overview effect. And how do you feel about fellow humans on Earth? Okay, I'm going to close there and say thank you. Thank you very much. And I hope we have time for some questions.
Yes, sir, we certainly do. That was wonderful. And I hope the students can appreciate what you're trying to do. And I have a question. Was the last video silent because people were saying they couldn't hear? Oh, now I can't hear you. You're muted.
Yeah, I muted because can you hear my dog?
No.
Oh, okay. My dog is barking because she's a guard dog. In her own mind, she's a guard dog, and she thinks there are terrible, terrible people outside.
Oh, okay.
Okay. Yeah, there was just music, so you didn't miss anything.
Okay, perfect. So the questions are, Dr. White, your book was published in 1987 and astronauts read it before going up. Has anyone ever told you that the book was actually in their mind when they looked back at Earth from up there?
That's a really good question. One astronaut told me I knew about the book and I consciously did not read it because I wanted to have the experience directly.
That makes sense.
Yeah.
Yeah.
Most NASA astronauts said that they told me they were aware of the overview effect, but they wanted to have their own experience of it. The more recent commercial astronauts are much more likely to have read it. And over time, I do think the experience has changed because initially, when astronauts were flying, they weren't expecting to be shocked by what they saw. More recently, people, even if they haven't read my book, they've heard I'm supposed to have an experience of some kind. So commercial astronauts actually pay money to have this experience. So I don't think I've ever heard anybody say, I read your book before I went, but many people have gone and said they were aware of the phenomenon.
Wonderful. Basmala, would you like to ask a question?
Hello, Dr. Frank. I am grateful for this chance. I am Basmala Muhammad from Dix Lab 2. I have a question.
Go ahead.
You have reviewed I have interviewed more than 50 astronauts over the decades. Is there one astronaut who said something to you that changed your understanding of the overview effect in a way you never anticipated?
Hmm. Yeah, a couple of things, I think. One is more people are talking about the Earth being a living organism and not just a system. I see more of my interviews getting into the Earth as being alive. And when I first started, I didn't hear that. The other thing is that after interviewing so many people, I've been able to boil down the meaning of the overview effect into three words: truth, love, and identity. So this is more what I've come to understand it to mean. One is, as I talked about, the geocentric view is not really accurate. We are actually moving through the universe, and we really are on a spaceship, and that's the truth. Our senses, when we're on the surface, don't give us the truth. The other thing that was surprising is how many astronauts tell me they came to love the Earth, and how many astronauts told me they cried when they first saw the Earth, and they were emotional about it. That's been a change over time. One thing that was constant is the idea of a shift in identity. Definitely, there's a shift from me to we, from my own individual good to the common good. And the other surprise, I'll just close with this, is that a lot of people did not think that you could experience the overview effect on a suborbital hop, where you just go you don't go far from the Earth and you're not there for long. But the commercial astronauts are having quite profound experiences. And I didn't know if that would be true until I started interviewing them.
Wonderful. Do you have time for one more live question and one more written question?
Okay.
Okay, Mohammed.
Thanks, Mr. White. Thanks a lot, Mrs. Nicole. Okay, Mr. White, I was so happy with all of the videos or all of the videos of Artemis mission. So my question is so near psychological for all of these missions. Okay, the question is, example, if my rocket will be published or will be launched outside any outside moon or outside Earth to any another planet outside the sunrise or sun collection. If my rocket will be launching or will be landing on the another planet, okay, in a certainly point, this certainly point will be the intersection between the planet and the landing of my rocket. So the question is, if I didn't have all of the mathematical solving of that, how can I psychological make or classify all of my psychological solving for the astronauts to make them more suffer or more safe in the landing or in the processes of the landing? And thanks a lot.
So I think your question is how to ensure the safety of the astronauts when they land?
Yeah, exactly.
Yeah.
Yeah, the landing.
Yeah. Well, that's really going to be a question for engineers, and I'm not an engineer, but I think that the way NASA is approaching the whole thing is to start with the moon and learn more about Mars by landing on the moon and learning how to survive on a lifeless place where you're going to have to depend on the Earth to survive. And so I think landing and how the rockets function and all of that we're going to learn a lot from building a moon base, which we're planning to do. However, I do think landing on Mars is going to be hard. It's going to be difficult. It's going to be dangerous. And so I don't know if it'll ever be completely safe. And, you know, Elon Musk, who wants to live on Mars, said he wants to live on Mars and he wants to die on Mars. He just doesn't want to die on landing. And unfortunately, it's about a 50-50 chance that he might die on landing.
Yes, I agree. There is no guarantee in space,
None.
anything, even before you leave the Earth. There's no
No,
guarantee.
no guarantees.
No. Last question, Dr. White. You described the overview effect as a shift in consciousness rather than in information, meaning the astronaut learns nothing new but feels something different. Do you believe that kind of shift is possible for an ordinary person who will never go to space? And if so, how?
Yeah, that's a very good question. So, at the simplest level, I think we can have analogs of the overview effect, and we can create analogs, especially with virtual reality. I think virtual reality is going to help a lot in reproducing the overview effect. So, that's one very direct way. Beyond that, I have said to many people that there's a distinction between the overview and the effect. The overview is to see the Earth from a distance. The effect depends on the person. And the effect actually is very similar to other kinds of experiences that we have on Earth with meditation, near-death experiences, and other experiences like that. So I do think it is possible to have a similar, although not exactly the same experience where you begin to relate to the whole more than you relate to the parts. And one of the areas that I'm interested in looking at is how do these different kinds of experiences compare to one another?
Thank you. That's a beautiful answer. Is it Dr. White? Am I saying that correctly?
No, I just accepted the doctorate. I
Okay.
don't really have a doctorate, but I
We're just
accepted it.
we're gonna
For,
go with it.
for 40 minutes, I can be a doctor.
That's right.
But thank you for that.
Thank you so much for being here and sharing that beautiful, beautiful presentation. And it's something I think left-brained people don't think about the beauty of, and it's important to bridge both the engineering and the science and like in the movie Contact. I don't know if my favorite
I've seen
movie
it. Yeah,
where
Chris
Ellie
River.
says they should have sent a poet
Yeah,
because it's
absolutely.
not always about, the nuts and bolts. It's about the feeling. And so it's a
Yeah,
beautiful addition to this project. Thank you so much.
great.
Students, remember Monday we start 1 hour later with Dr. Arobi Das, and she will be here, and then I can answer questions about your projects. I am in the middle of trying to find mentors for those of you who need a mentor or request a mentor. You have to tell me if you want a mentor or need a mentor. So please email me. I will upload this to YouTube. And I will send out all the usual information for the next few days. And always email if you have any questions or issues. And thank you all. I'll see you Monday, 1 hour later than normal.
Goodbye, everyone.
Thank you. Bye, everybody.
Thank you.